Hello, students, and welcome to another lesson with Mr. Kennett at home, watching our flipped video lessons here. Glad our round one went quite well. So as you can see, today's lesson is 3.2, and we're talking about rational numbers. And the first thing I want you to kind of pay attention on rational numbers is this word right here that is stuck on rational numbers. That's the word ratio, and it really has some significance on why we called them this. Our essential question today is how do we order and compare rational numbers, and how do we classify real numbers? And that's our heading. So if you want to pause right now and start copying down what you see, the real numbers table on this right slide here, please make this about half a page inside, if not the whole page, because we are going to add things into those sections of rational numbers, integers, whole, and natural. So we're going to write in those things, so you have to make it large enough to write in. Okay, go ahead and pause. Welcome back from the pause. Hopefully everything got copied down correctly, and hopefully I don't have my cursor in the wrong spot again. Maybe I need to move it a little bit. Okay, so let's start with the smallest classification of numbers. So what we're learning is this world of real numbers. And there's two segments of real numbers. We have rational numbers, and then we have this separate segment to the side called irrational numbers. And both of these types live in the world of real numbers. And if you ask me about in class, I'll tell you about the world larger than real numbers called complex numbers. There's actually a larger category. But we're going to start here with natural numbers. Now, natural numbers are those first numbers you ever learned about in your math class or in counting in general. It starts with a number 1, then it goes to 2, and then 3, and then we use our ellipse signal to signify this pattern goes on forever in that direction. And those are our natural numbers. Whole numbers are a little bit different. We have to include a special number that actually came into existence after the number 1. It's the number 0. So whole numbers start on 0, then go to 1, 2, 3, and then we use our ellipse showing this pattern goes on forever. Integers are all whole numbers, 0, 1, 2, and 3, and their opposites. So what would the opposite of 1 be? You're right, -1. And the opposite of 2 is? Yeah, -2. So how we actually have to start showing integers is you actually have to start showing this dot, dot, dot first because it goes on forever in the negative direction as well. And then I'm going to start showing the numbers, -2, -1, 0, 1, 2, and it goes on forever in the positive direction as well. So those are our categories, natural, whole, and integers. And really this section of the math is getting to the next part called rational numbers. And rational numbers are any number that can be written as a ratio of integers. So it's any number you can write as a ratio of integers. And for example, a rational number is any repeating or terminating decimal. So let's start with an obvious one. Does this number 2 terminate? Yeah, it does. So 2 is still a type of rational number. And you may actually notice how 2 is a natural, 2 is a whole, 2 is an integer, and 2 is a rational number, and 2 is a part of the real numbers. So this is like an umbrella. You can be a part of anything above, but it may not necessarily be in the parts below. But if you're in a lower part, you also exist in the higher segments as well. So another rational number out there could be like 2/3. We could have -0.4. It could be 5. And there are tons of other rational numbers, and I'll start asking more about that in class. Now, this side segment called irrational numbers is any number that can't be written as a ratio of integers. And the most famous irrational number we have ever learned, you all have heard about this irrational number before. It's used a lot. We love to celebrate it in March time, and you love to bring in some sweet desserts for this. What is that irrational number actually called? Yes, you're right. It's pi. And if you did not know, pi is actually spelled P-I, and pi never terminates and never repeats as far as we know. Now, there are some other irrational numbers we're going to start learning about, like square roots that are unsolvable. And if you don't know what a square root is, don't worry, ask me about that in class and I can try and go over that. So moving on, that was our categories of real numbers with just the bare minimum of examples, and we'll talk more about that in class. Now we need to use that information to start trying to identify all sets to which each number belongs. So I'm going to pause here, or have you pause here, while you copy down problem 1, and do leave some space after each of these problems. We're going to fill in the words below them. Okay, welcome back. -2 over 6/11. Well, since we have a fraction on this mixed number here, it's not possible to be a natural number. It's not possible to be a whole number, and it's not possible to be an integer. So the first category that -2 and 6/11 actually falls in is rational numbers. And I'm going to use the number symbol. You may call it a hashtag, but it also stands for number. And the other category it also falls in then is real numbers. Okay, that's problem 1. Now, when you copy down number 2 here, the problem, please copy it down really carefully. And I'm actually going to go over number 2 in class so we can discuss why it has this classification that it has. So let's look at number 37. 37, what is the smallest category in this umbrella diagram we have to our left here that 37 falls in? Yeah, you're right. It falls in that natural category, the very smallest. And if it's a part of the natural, it's also a part of the whole. It's also a part of integers, rational numbers, and real numbers. And this is like an example how though you may be classified as a boy or a girl, you have better names and better classifications for you. So although 37 is a real number, its most specific classification would be natural number, because that is the smallest category it belongs in. Okay, we're moving on. When we order our numbers, we actually started to learn this in our last class. We have to compare like with like. And if you look at this list of numbers right now, you may notice that we have a mix of fractions and decimals. And it's hard to compare fractions to decimals unless they are like each other, meaning they're all decimals or they're all fractions with common denominators. Due to our large mixture of fractions and decimals with all different denominators on the fractions, I believe the best path for this is going to be converting these numbers all to decimals. So what I'm going to have you do is, can you please convert 1/3 into a decimal? Can you convert 5/13 into a decimal, and -5/3 into a decimal. And I know I wrote mine right on top of each other, which you know I'm going to pick on. So leave some space. It was just, I was very limited on how I showed it. And I'm going to ask that you show those divisions on your own, and then I'll give you the answer back in class. So if you haven't finished yet, you want to copy those down. And then our last page here of my presentation, problems 5, 6, 7, and 8, are actually from the 3.1 lesson. So use your 3.1 note to complete this part. Okay, and I'm actually going to check these problems in class to make sure you understood how to use the 3.1 note to turn these fractions into other types of numbers. If you have any questions, please ask in class. Write them down on your Cornell note. Remember, that's a great way to remember what question you wanted to ask me right now, so you don't claim you forget it tomorrow. Just like our signs. I hope you enjoyed this lesson, class, and we will discuss it more tomorrow.